Section 3.1 Objectives. Number 1, recognize characteristics of parabolas. Number 2, graph parabolas. Number 3, determine a quadratic function's minimum or maximum value. And number 4, solve problems involving a quadratic function's minimum or maximum value. Ready? So first of all, I want to remind you of some vocabulary changes from Algebra 2 to college algebra. Okay? This they call standard form. God bless you. God bless you. Where is the vertex in this form? HK. Okay? This is what we called standard form. They call it general form. Okay? Pretty easy switcheroo here. Just clearing up vocabulary issues, okay? So if I give you an equation like y equals 2x minus 4 squared plus 5, can you tell me where the vertex is? So it's just 4, 5, right? Because remember, it's x minus h in the formula, and if it's x minus 4, then our h is just 4, right? So could you find the vertex? Yes, right? Could you graph this parabola? X-axis and y-axis. Where's the vertex again? 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Does this open up or down? Up because this is positive, right? Is it parent function shape? Like this? Or is it steeper? It's got a multiplier of 2, so we know it's steeper, right? So instead of going over 1 and up 1, I would go over 1 and up 2 because I would multiply that y value by 2, correct? And I know it's symmetric, so I can go ahead and put that over here. Instead of going over 2 up 4, I would go over 2 up 8 because 4 times 2 is 8. Now I can't really do that on this graph paper, so what I can see is that right there, right? Okay. So on this particular parabola, does it have a minimum or does it have a maximum? Why is it minimum? It has a lowest point, right? And where is the minimum of this parabola? 4, 5. It's at the vertex, right? For a parabola, if we're determining a quadratic function's minimum or maximum, I think I said that backwards, but whatever. We're looking for the vertex, aren't we? Okay? Whether it's like this, where it would be a minimum, or if I graphed it and it actually like this, wouldn't this be a maximum now? Yeah? That's going to be the vertex, isn't it? So keep that in mind when it's asking you to find the minimum or maximum. It's just asking you to find the vertex. You just got to know if it opens up or down to know whether it's a minimum or maximum, right? Okay? Now, graphing parabolas, not taking a whole lot of time on that because we just got our calculators, right? Okay? There's not going to be too many times where I ask you to graph without a calculator. Okay? Part of the things that I have to teach you in Algebra 2 in high school is how to do it with a calculator and how to do it without a calculator, right? Okay? I just showed you on this page, on this graph right here, how to do it without a calculator. Okay? I don't think I have to show you how to do it with a calculator, correct? You just like punch buttons and hit enter, right? Okay? So, any questions about recognizing characteristics of a parabola? What characteristic is the most important of a parabola? The vertex, right? The vertex for sure, okay? Because that vertex will also be the minimum or maximum depending on whether the parabola is opening up or down. What other characteristics we care about a parabola? Well, we care about its general shape, right? First of all, we care if it's opening up or down. We care if it's narrower or wider than a parent function parabola, right? Because if it's a parent function parabola, that means there's not a multiplier on the front at all. And no matter where my vertex is, I would go over 1 up 1 because 1 squared is 1. I'd go over 2 and up 4 because 2 squared is 4, right? If I could, I'd go over 3 and up 9 because 3 squared is 9, right? That's true if it's opening up, right? If it opens down, even if it doesn't have, or especially if it doesn't have a multiplier, I just find the vertex and do the opposite of that. Over 1, down 1. Over 2, down 4. Over 3, down 9, right? Okay? Any questions about recognizing characteristics? Any questions about graphing parabolas? Any questions about determining a quadratic's minimum or maximum value? Well, go ahead. If it opens this way, this is the maximum because that's the highest point that the parabola will get to. If it opens up, this is the lowest point it will get to, so that's the minimum. Okay? Now, this is all fine and good if we have standard form, right? What happens if it's in general form? General form, you can do it, it's just not as easy, okay? So I want to make sure that you remember what general form is. And in general form, you find the vertex by negative b over 2a. Do you remember that? Negative b over 2a. And the y value is the value of the function at negative b over 2a. So all the characteristics and graphing and quadratic minimum or maximum, we talked about when we have standard form, right? So let's talk about those real quick in general form. Are you okay with that? So if I give you, I don't know, y equals 4x squared minus 5x plus 2, can you find the vertex? Well, I didn't even choose nice numbers for you, so I'm sorry about that, but you'll live. To find the vertex, we use negative b over 2a. Well, what's the opposite of b? 5 over 2 times a. What's 2 times 4? 8. Okay. So in order to find the y value of this vertex, what do I have to do with 5 over 8? I have to plug it in for x. That's why I said I didn't even choose nice values for you, right? Because those are fractions. So we have 4 times 5 over 8 squared minus 5 times 5 over 8 plus 2. Well, we're not children. We can figure this out, right? Well, some of you are children. Okay. So I have 5 over 8 squared. Well, that's just 25 over 64, right? Times 4. I could just multiply straight across, or I could simplify first, right? So this is a 1 and this is a 16. So I have 25 over 16 minus 25 over 8 plus 2. What do I need in order to add or subtract fractions? Common denominator. What would be the common denominator between these three terms right here? Correct, 16. $25 over 16 minus 50 over 16 plus 32 over 16. Well, 25 minus 50 is negative 25. What's negative 25 plus 32? 7. So my y value would be 7 over 16. Did I choose a hard one on purpose? Yeah, right, because you could do the easy ones. If this was a 2 and this was a 1, that would be super easy, wouldn't it? Negative b would be negative 2 over 2 times a, which would be 2. So my vertex would be at 1, or my x-coordinate would be at 1, and then I just plug 1 in for x to find my y value. Yes? Okay. So a vertex, no matter if it's standard form or general form, is an important characteristic, isn't it? Something else in general form that's an important characteristic, well, it's important to standard form too, it's just not as easy to see. But in general form, C is your y-intercept. That's nice because it's super easy to see because it's right there. It's the constant, right? So one more time talking about minimum and maximum real quick. Are you okay with that? If this is my parabola, how am I going to know whether it has a minimum or maximum? What has to be true about the a value in either form, standard form or general form? So if a is less than 0, that's going to be what? It's opening down, so that will be a maximum, right? And if a is greater than 0, if a is positive, like this one, my vertex will be a minimum. Does that help a little bit? Yeah? Do you have any questions about any of these objectives? Do you remember a lot about parabolas? Yeah, we worked on them pretty hard in Algebra 2, didn't we? Okay? If you do have any questions when you get there, please ask. Okay?